Assalamu alaikum. Today's topic is normal distribution, the quantiles of the normal distribution. We have studied the standardization. Now, today's topic is de-standardization. In de-standardization, Z standardized variable is given whose value is denoted by small z and random variable x which follows normal distribution is unknown, and unknown value can be calculated using the expression x is equal to mu plus sigma z. As we can see from the expression, if z is the standardized variable which is equal to x minus mu over sigma, if z is equal to this one, then x can be calculated from this expression, which is x is equal to mu plus sigma z. In this expression, z standardized variable value is given, and x, the normal variate, is unknown. And mu and sigma are the parameters of the normal distribution which are also given. So we have three values, mu, sigma, and z. And for these three values, we have to calculate x. So corresponding value of z, we can get x. Standardization and de-standardization. Then the concept of quantiles of the normal distribution, in which initially we have to calculate the quantiles from the standard normal distribution, which are equal to probability z less than small z, which is denoted by phi of z. Come to the figure. In the figure, there is a z scale starting from -3 to +3, and mu is in the center, which is 0, and height is ordinate, maximum ordinate is almost zero point 0.4, and a specific value on this z line is, for example, this is zp, and the probability is denoted by small p, which is the shaded area below this point zp. So p is the probability which is the shaded area from minus infinity to zp, and this p is also denoted by, this shaded area is also denoted by capital phi of z. So probability z less than z is phi of z, capital phi of z, and we are taking its value as p. If p is equal to this one, then z can be obtained. P is on the left side whenever it comes to the right side, so it's inverse, phi inverse of p. So z can be obtained phi inverse of p, which is the standardized normal variate. So this is the value of standardized normal variate z. This is the first step in which we have calculated the z value, and then using this z value we can convert it into x and obtain the quantiles of the normal distribution, because this is the standard normal variate and value of standard normal variate, and whenever it is converted into the x, that is called quantiles of the normal distribution, using the expression we have studied on the previous slide, this one, x is equal to mu plus sigma z. Once sigma z is calculated or obtained from the expression phi of z, and then we can calculate x using this expression. So 100 pth percentile of the distribution of standard normal variate z is the value of zp, which can be obtained from this expression, and this z is the same one, zp, or simply the z. And after that value, we can obtain 100 pth percentile, which is xp of the normal variate x, and x follows normal distribution of mean mu and variance sigma square, and standard deviation is sigma, and x is a random variable, follows the normal distribution, that's why it is capital X. Mu plus sigma are the parameters of the normal distribution, and Z is the standardized variate follows the standard normal distribution with zero mean and unit variance. So Z and X both are the variables. That's why they are written here in this expression in a capital letters. When we are substituting their values, corresponding values, they are denoted by small xp, and Z is denoted by small zp. The expression will be the same. Xp is equal to mu plus sigma zp. And this expression is used to calculate the value of the xp, which is the quantile of the pth quantile of the normal distribution. We are now coming to the next topic, in which finding the value of parameter or parameters. There are two parameters of the normal distribution, mu and variance. In some situations, these parameters are unknown, or one of these parameter is unknown. Um, we are considering this example in which mu is unknown. If x follows normal distribution with mu and variance is 25, so mu is unknown value, and probability x greater than 69.6 is given as 0.017, and we have to find mu. In some situations, mu are unknown. In some situations, sigmas are unknown, and there may possibly exist situations in which both mu and sigma are unknown. So a solution involves, first of all, we consider this probability. Probability x greater than 69.6 is equal to 0.017. So I'm writing here this expression. I subtract the probabilities from 1 minus this expression, and 1 minus 0.017. Whenever 1 minus probability x greater than 69.6, it will be converted, and this expression can be written in this form: probability x less than 69.6, and the 1 minus 0.017 is equal to 0.983. And this probability x less than 69.6 is converted into the standardized variable, which is this one. At x is equal to 69.6, z will be 69.6 minus mu over sigma. Because we don't have the value of mu, we can't calculate its numeric value, z, and calculate the mu from this equation. So this is the equation in which we convert x into z and 69.6 into this expression, and then we can write it in the form of capital Phi, because probability z less than any specific value can be written as capital Phi of that expression. So the next step is this one: probability z less than that expression. Because mu is unknown, we have to write the whole expression here, is equal to 0.983. Now we can convert probability z less than into phi of this expression. And in the next step, phi is on the left side. Whenever it comes on the right side, it is written as phi inverse of 0.983. And we are using the table 10a, in which phi inverse values are given. So come to the table. This is our table 10a, and in the column probabilities are given. We have to search 0.983, which is in the bottom. This is 0.98 under the column 3. This one, this is 2.1201. So we are considering this value of phi inverse of 0.983, which is equal to 2.12. So we will write this result in our slide. So this is 2.12 and 69.6 minus mu over 5. Solve this expression, solve this equation. For the unknown value of mu, we can get the value of mu as 59. Consider this shape, the curve, which is the normal curve, normal distribution, because there is a x random variable, and f of x is the title of this curve, which shows that this is a normal distribution. It's a density curve, and the probability which is given in the question is x greater than 69.6. So this arrow, black arrow, shows this point is 69.6, because 0.017 is very little probability, and above this point probability is 0.017. So if this point is almost near to this tail, so that the shaded area is very little, about 0.017, and the remaining shaded area on the right side will be 1 minus 0.017, which is equal to 0.983. And we know that phi is the area which starts from minus infinity to that point. So this area is called as phi. So 0.983 is here written as phi of this point, and this point is denoted by this black arrow. So the point on the number line here is 69.6 minus mu over 5 on the z scale, corresponding z scale. For example, I am drawing here one more scale, for example this one, and this scale is used for the z. So the point on this number line is, for example, this one. So this point on the number line is, we can say, is r 69 point, this expression, minus mu over 5. So this point is can be written as, this is r 69.6 minus mu over, because mu is unknown, so we have to write as mu, and sigma is given as 5. So this point is on the z scale. Mu, which is our mean, lies in the center. So in the center there must be 59, and definitely 69.6 is on the right side. That's why black arrow is on the right tail, and 59 is less than 69, so it should be in the previous point on the number line, and it's in the center of the distribution. So mu is 59 in this case. This is an example in which mu is unknown, and one more example, if mu is given but sigma is unknown, we can also solve them. And if both mu and sigma both are unknown, then we can also solve the problems. So come to the book. In the book, question 10 point, look, it's 10.15. If x is normally distributed with mean 50 and variance sigma square. In our case, in this question, sigma square is not given, and mu is given as 50, and probability x less than 60.6 is equal to 0.983. By chance the value is same one, 0.983. Find the value of standard deviation sigma. Okay, this question is same, but here mu is given 50 and sigma square is unknown. You can write in the same lines and solve the same problem in the same way. So come to the next example. Is next example, you can see 10.16. In a normal distribution, 33% of the values are under 48. For example, if we draw here a line which shows that distribution, for example, this is our number line. We must draw two number lines, okay? One for x and one for z. And then plot the curve for example, this is our curve. In the middle, there must be value of mu, and in z scale, it's first we write it as z and then x, or x or z, anyone. Okay, so our value 33% area. You should know 33% of the values are under 48. This shows 48 is here, because under this point 33%, you know, in the middle there are 50% area. So below this point the area is only 33%. So we can write it as the shaded area, this one, and the point on this number line is as, this is our 48. This point is 48. And this probability is how much? If I write it as in not in percentage form, I want to write in points, then it's equal to 0.33. Okay, so this area is 0.33, and you can write it as, initially you have to find this z, okay, this z, 48 minus mu over sigma is equal to 0.33, and this is called our probability, so we can write it as small p. One more expression is given here, 12.3%. So how much area is this one? 0.123. 0.123 are over 60. Over 60 means 60 must be here, and over 60 this shaded area is only 0.123. So the area below above this point, the word over shows we are going to shade area above the point 60. So 60 is here, so we can write it as, this is 0.60, and corresponding value of z we have to find. This an expression involves 60 minus mu over sigma, and this probability is given as 0.123. Now we will make two equations. The example we have done in presentation, having one unknown value which was mu, so there should be one probability given, and one equation is obtained to solve the value of p, to solve the value of mu. In our case, mu is unknown and sigma is also unknown. If mu and sigma are unknown, there should be two equations, one equation from here and one equation from here. Then you can solve the two equations to obtain the value of two parameters. If there are two unknown values, there should be two equations to solve them. So number of equations should be equal to number of unknowns to solve them. So there are, you can see there is a line between them. One portion is on the right side, one on the left side. So two equations are obtained and solve them simultaneously. You can get mu and sigma. So you, I think you probably solve it. And 10.17 example, if a normal is if x is a normal random variable with parameter mu 50 and sigma 10, both values of parameters are given. Find its mean, median and mode, and lower and upper quartiles, quartile deviation and mean deviation, variance, standard deviation, all four moments, about mean, moments ratios, and moments coefficient of skewness. We have studied the properties of the normal distribution in the start of the chapter, in which properties are this one. You can see first property, continuous variable total area mode is obtained by this expression. So if mode is given you have to find, then use this one. And symmetrical distribution, all ordered moments are zero, so using this property, mean, median, mode are equal to mu is given, so all these are equal to, so you have to use these properties to obtain the results. Not numerically you have to solve them, just write this property: mean, median, mode are coincide at mu, therefore mean is equal to median is equal to mode is equal to mu is equal to your specified value in the question, which is I think 10, or 10 is sigma and mu is I think 40. So you write directly 40 here. Lower quartile is this one, x x 0.25, and upper quartile, that is Q3, is obtained by 0.75. So both are equidistant. Using these properties, x 0.5 is equal to mu, x 0.25 is equal to mu minus 0.6745 sigma to obtain the first quartile. For the third quartile, use this expression. For quartile division, use this expression. Sigma um, is equal to this expression or 2 by 3 sigma, both. So mean is obtained by this one. Mean is not obtained. You don't need to use these two expressions. Only quartile deviation is required. So use this expression. Come to the next property. In next property, variance is given. So mean deviation is equal to 4 by 5 sigma. Use this expression to obtain mean deviation. And beta 1, beta 2, the moment ratios for from this expressions, in which you can see only sigmas is involved. Okay, so write the sigma here, and I think that's all. Or nothing is more required for the example. Come to the example again. This one. Okay, so all the properties are used to obtain the quartile deviation, mean deviation, standard deviation, and skewness, curtices, beta 1, beta 2, mu's. Okay, so 10.18 example, in which in a normal distribution, lower and upper quartiles are given. It means x 0.25 is given, x 0.75 is given. Then find mean and standard deviation, again using the properties which were I said don't use them. Now in this example you are using those expressions to obtain the value of mu and sigma. So using the properties you can solve these two types of examples and such questions from the exercise. So you should learn the properties so that you can make use them to obtain the results in the questions. So okay, thank you so much for today.